So today is the 19th. And we are going to start today solving exponential equations. And to be clear, exponential equations are not equations that have exponents. They are specifically equations where the variable is in the exponent, okay? So you've been solving equations that have exponents since algebra 1, like x squared minus 2x minus 12. That's not an exponential equation. Okay, that's a power function. It's a quadratic. But to be exponential, your variable has to specifically be in the exponent itself. Okay, so today is pretty much dedicated to teaching you how to solve those. And to be clear, I'm not talking about equations like this. Well, let me ask, is that an exponential equation? Does it have a variable in the exponent?
Yeah.
Then it's an exponential equation. But I'm not going to insult your intelligence by spending the period talking about things like this. The answer is obviously 2, right? Because you'd have to do 3 to the power of 2 to get 9. So we're not going to solve equations that we could solve through just simple inspection. We're going to solve equations that are more difficult, nigh impossible to solve like this. And the idea here is you may not know that you know this, but you do. The answer to this problem has to be 4 point something. And the reasoning behind that, and I say this because along the way you can always check to see if your answers are sensible. And what's 3 to the power of 4? I'll have a sip of coffee while I wait for your help. It is 81. So if 3 to the fourth is 81 and 3 to the fifth is 243, then logically, the solution to this equation has to be between 4 and 5, right? So as I show you how to do this, just have in the back of your mind that you want to always try to police yourself, be the reasonableness police, and ask yourself, is my answer like kind of where it makes sense that it ought to be? You all right there, buddy?
Yeah, I had bad itch in my back.
Uh,
Spot I couldn't get to.
maybe you ought to have LT scratch it.
Honestly thought about telling him to do it for me.
Don't you mean asking him to do it?
Asking him,
There,
yeah.
that's better. I forgot. I'm recording this for another class. I need to stop with stupid ahernisms. So, um, let's get back to it. So here is how you solve an exponential equation. The first thing we're going to do, and you won't know why yet, is we're going to, you remember the problems on the last quiz, how we could drop a log, drop the logs? We're going to do the opposite of that. And instead of dropping off logs from each side, we're going to introduce logarithms onto both sides for reasons, again, that you don't yet understand. So let's take this equation and let's rewrite it as the log of 3 to the x equals the log of 112. You'll notice that I elected to not use a specific, like I didn't say log base 3 or something like that. What base am I using by default? 10. And the reason why is in most cases, 10 is going to work well because your calculators that you all bring with you every day, they have a button that says log, and that button by definition uses a log with a base of 10. So that's why when we have this step where we're going in and we're introducing a log, we want to use the base 10 log so it's easy to put into our calculators. We're going to be doing a lot of heavy calculator work today and probably Monday. Okay. So having said that, if you're shuffling around, I need you back because this is why today's lesson exists. There is one property of logarithms that is more useful than all other properties combined. And I don't think there's a math person out there that would disagree with what I'm about to say. There is a property of logs that states that if you have, you might want to write this down, if you have a log of, so we'll say a to the power of m. And I just picked m because I don't like b's because a lot of times people think they look like sixes. So in a book, you'd probably see it as log of a to the bth. I just chose m's because no one ever thinks m's look like anything other than m's. A fact is this: the single most useful property of logarithms states that you can take your exponent on the argument of your log and bring it down in front. And if you're not aware, like instantly, of how amazingly, insanely powerful and useful that is, you soon will be. So what this means is if I have the log of a to the power of m, I could slash probably should rewrite it as m times the log of a. It's a game changer because what it does is it takes the exponent with the variable that's currently like sort of untouchable, if you will. Like we in Algebra 1, we teach you how to divide both sides, multiply both sides, add to both sides, all these different things. But we don't really have a tool at our disposal for how can I solve for X when he's cowering and hiding up in the tree. And so we bust out the big guns for this, the most useful gun, and we apply a logarithm and then use the property to pull the exponent down in the front. Massively useful. What does that mean for us over on the left? Well, it means that we can now take that x that's hiding from us, and we can only do this because we applied a logarithm. But we're going to take that x and we're going to bring it down in the front now. And we're going to rewrite this equation as x times the log of 3 equals the log of 112. Again, absolute game changer because now it's going to be calculator to the rescue 100%. So, assuming you brought your calculator today, you're going to want to grab that out. If you're one of those people that borrows mine in the bag, they are not going to help you at all today. So, grab your calculator and you're going to want to type in this. I'll kind of guide you through what buttons to push. You're going to hit log, and I do believe your calculator is going to give you a parenthesis. Is that about right?
Yep.
And then you're going to hit 112, and then you must close that set. You want to tell your calculator that, hey, I only want you to take the log of 112. If I keep this set open, then it keeps adding to the argument of the first log. Don't do that. And you don't have to hit enter if you don't want. You can just hit divided by and then do another log, and it's going to give you another parenthesis. You're going to do 3. You're going to close, and then you're going to hit enter. And why I had that conversation with you before was so that when we do this, so that when we hit equals, which I'm going to do with you right now, because I don't know what the answer to this is. I know it's between 4 and 5, but I don't know anything beyond that. Oops. There it is. And my directions for you are for the coming days, probably a week, I'd say, between assignments, practice, quiz are going to be, we're going to round to 4 decimal places. We refer to that as the 10,000ths place, but that is 4 decimal places. So because my calculator tells me that X is about 4.294962763. Rounding goes like this. If your teacher says round to 4 places, what you do is you go and you underline the 4th place. You don't have to. This is just how you do it. And then you look 1 place to the right. All this other stuff is meaningless, okay? Only 1 place to the right. No chain rounding. 1 place only. What will that 6 do to that 9? It rounds it up. And what does a 9 go up to? A 10. And when you can't hold a 10, we only have 9 digits in our system. 10 requires 2 places, right? So we say then that our answer X is approximately equal to 4.2950. That 9 going up to a 10 caused us to require another decimal place, right? Thank you. You're good. Appreciate you. All right.
Let me know if that dollar amount's right.
Okay.
I have 10.
Appreciate it. How'd that feel? And we knew what was coming, right? And you don't have to analyze it ahead of time if you don't want to. I'm just saying it's good to know ahead of time, like ballparky what to expect. And then if I had got something hilarious like, 13.6, I'd have said, no, 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 pump the brakes. There's no way that that makes any sense. 3 to the 13th power is astronomically large, right? Well, not astronomically perhaps, but it's really big. So there you go. That's how you solve a log equation or an exponential equation, excuse me. Now let's do a handful more. This is how we do things around here. So this time we're going to have 8 to the power of n minus 1,238 equals negative 56.
Oh boy.
I didn't really step it up much. I'm very cognizant of what I call scaffolding. So when I write your lessons, I'm aware of not going too fast. Okay, we're going to add a little bit and then a little bit more until eventually the problem that would have looked impossible a half an hour ago is light work. You see something new. What do we have to do? Just follow your instincts. You know this. You got to move that 1238. We've been doing algebra for years, literally years, and we know that the minus 1238, like any other instance, is he's an annoying, I call them stragglers in algebra one, I think. Just get it out. And so we're going to leave 8 to the nth here. We're going to add 1,238 to both sides. So we're going to do negative 56 plus 1,238, and we're going to get 1,182. And this one's a little bit harder to eyeball. I mean, what I can tell you is that 8 to the third, you all know, is 512, and 8 to the fourth is what, 4,096, I think. So clearly, again, we're dealing with something we can kind of already eyeball it and say it's going to be between 3 and 4. So here in a moment, when we calculatorize this, if we get something other than 3 point, then we're going to go, nope, I cry foul. So step one, quick, go. What is it? Log both sides. Good. So we're going to have log of, not times, log of 8 to the power of n equals log of 1182. Good. Next step. Yeah, a good finger gesture. I appreciate. Take the n and zoom, drop it down in the front. So we wind up with n now times the log of 8 equals the log of 1182. And I honestly, I didn't show my work on the last problem, so let me do this. So, and then I won't do it every time. But you've done algebra enough, you know that we're dividing both sides by the log of 8, right?
Oh.
And you will start to skip steps. Eventually, you will, in your own time. I'm not going to push it on you this early, but you will start to do enough of these that you start to see some things where you can cut some corners. There will be some steps that you don't have to do. So we're all together going to do the log of 1182, close those parentheses. We're going to divide by the log of 8, close that second set of parentheses, and right on cue, there's our 3 point something. So if we round this to 4 places, we'll say n is approximately equal to 3 point what? 4023. No modification necessary on this one because the number after our guy is another 3 and he won't affect him. Any questions about that? I'm going to call a quick audible on myself. I did not have this as part of the lesson, but I feel like I kind of maybe dropped the ball on this. So I'm going to throw in 2 examples real quick that were not on my note card. The first one is this. Let's do 10 to the power of x equals 46,231.
Wow.
Again, you already know, I assume that the answer is between 4 and 5 because 10 to the fourth is 10,000 and 10 to the fifth is 100,000. So we know already what to expect. We're going to log both sides. And you'll notice I just skipped a step for the first time. Did you catch that? You see the writing on the wall. You know why you're logging, right? So you can bring the X down. So just 2 birds, 1 stone, right? 2 steps, 1 move. Just bring the X while you're logging. Let me ask you guys a question from a different test from a few weeks ago. Stop writing right now and listen. I just circled something. What does it equal? It equals 1. Thank you for your recollection from the past. I always love it when you guys remember these things. Remember that log of 10 means log base 10 of 10. And that's a redundant log because 10 to the power of 1 equals 10. When you are lucky enough to get a problem where the base of your exponential portion is a 10, this part right here, watch the magic eraser, you don't even need. Magic, right? So the answer to this problem is already on the board. I don't have to divide because I'd be dividing by a log of 10, and a log of 10 is 1. Who divides by 1, right? Weirdos divide by 1. So all we're going to type into our calculator this time is one simple logarithm. We're going to just do the log of 46,231. And as expected, we get that x is, change your equal sign to the squiggly equals. Whenever you destroy an answer by approximating it, make sure you change to the not sure of himself equals. And we're going to call this about 4.66 what? It's going to stay as a 4, 9 because the number after this 9 is a 3. So he won't, like that first one, cause us to go up. And the other audible that I have to call here is this one. And again, I hadn't really planned on this, and I don't recall if it's going to happen in the assignment, but here, imagine you have e to the x equals 5,012. Think smart. If you're still with me and thinking and actively involved in this, you can answer the following question. Let's not log both sides. Let's use a special log. Like what? How's about a natural log? And your calculator has a button for natural log, FYI. Could I do this problem by logging? Sure. Go ahead. I'm just saying I can use the same trick as I did on the last problem. If I use a natural log, I can do x times, woohoo, the natural log of e equals the natural log of 5012. I'm allowed to use whatever log I want. And what's so great about this? What does the natural log of e equal? It's 1. It's another redundant log. It's like saying what's log base e of e, and we of course know that that equals 1. And so again, with my magic eraser, I can say, look, because I chose to use a natural log, I don't even need that other part. All I have to type into my calculator is go find that ln button, natural log of 5012, close the parentheses, boom. 8 point what? I like that answer. X is approximately equal to 5. Oh, excuse me. That's not good. 8.519, and then round that 5 up to a 6. All right, I'm going back to my note card now. I'm going back. I took a little detour off the road, and now I'm going to hit back on the road. So let's knock out some problems. They're going to get a little harder to put into our calculators eventually, just for the record. So let's do -4 times 5 to the power of m equals -14,324. Step 1. Nope, there's no condensing. There are no logs. Someone just said it, but they said it quietly enough that I'm not going to acknowledge it. Divide. Right. Listen, you've been doing algebra for years, and you know darn well if I gave you like -4y equals -14,324, you wouldn't hesitate to divide both sides by -4. No chance. Same logic on this one, okay? So we're going to divide both sides by -4. Prep work. And we wind up with 5 to the power of m equals something. Say again. Nice. Can anyone look at this problem right now, having done a few? I think we've done 4 problems now. Could you look right at this and already tell me what I'm going to type into my calculator?
Yep.
What?
Log, you find it 1 divided by.
Excellent work. Again, if you're not ready for that yet, then let me show my work. But I'm just saying, if you see this now and already know what to type in, type it in. I'm good. But what happens is we get m times the log of 5 equals the log of 3581. And then you just divide both sides. So like Landon said, you could look back up here and already know, see the writing on the wall and just get ahead of the problem and just divide it. So we're going to do log of 3581, close parentheses, divided by log of 5, close parentheses, and I got 5.0846. So there is a line on my note card, and whenever I'm sitting at home and I draw a line, that always means something's about to change. So you might want to draw a line in your notes as well. Okay. So now the problems are going to get just a little bit different. 2 to the power of x minus 4 is equal to 321. Our approach, our thinking will not change. There'll be some different mechanics here in a moment, but the initial thinking is let's log both sides and drop the x minus 4. Here's what the next step is going to look like. We're going to have x minus 4 times the log of 2 equals the log of 321. Right. The worst thing you could do right now would be to distribute the log of 2. Math teachers are always like, oh, see parentheses, you better distribute. Not in this case. You would be very unwise to do that. What you want to do in this case is leave the x minus 4 alone and divide both sides by log of 2. Yeah. Like that. Now, let's you and I just talk basic algebra. What is the step that we have to do? As an algebra teacher, I want to hear you say this. What do we have to do to both sides of this equation? You have to add 4, right? So what we're going to type into our calculators is going to look like this. We're going to type in log of 321 divided by log of 2. Without hitting enter, we're going to hit +4, and then we're going to hit enter. So I'll work along with you. So log of 321 close divided by log of 2 close. Then just go ahead and hit +4. It's okay. What'd you get?
326.
Nice. So we have x is approximately 12.3264. Not that big of a difference, huh? Maybe not worth a line in the note card. I don't know. Let's press on and go again. Okay, we got 3 more to go. I'll try to get through these as quickly as I can. Our next one is 5 times 6 to the power of x plus 3 is equal to 2240. Step 1. Divide by 5. Right. Algebra will never, the rules of algebra don't change as math gets harder. Algebra remains a reliably consistent, predictable set of tools. So we now have 6 to the power of x plus 3 equals, what is that, 448? Okay, and if you wanted to estimate this, you could, but I leave that up to you. So at this point, next step, what do we do? You have x plus 3 times the log of 6 is equal to the log of 448. And then look at it, see the writing on the wall. If I divide both sides by the log of 6, and then I subtract 3, x is going to exactly equal the log of 448 divided by the log of 6, and then subtracted by 3. You see the pattern? It's the same problem as we just did, the same algebra results. So let's type that in. Log of 448, close, divided by log of 6, close, minus 3. I got something less than 1. You guys agree? So we're going to say that x is approximately 0.4071. Okay, final push. 2 more problems. Took a little longer, but it always does. We're going to have -3 times 7 to the power of 3x minus 4 equals -360. What do we do?
Right.
Yep. You'd be amazed how often, even after doing this for a week, people say stuff like add 3 to both sides. It happens even on the quizzes. So hold yourself accountable for that. You know better, right? That -3 is attached. So let's divide by -3. So we're going to wind up with 7 to the power of 3x minus 4 equal to 120. So we know the answer is going to be 2 point something. Not the answer. The exponent has to equal 2 point something. So x is going to be a little bit over. Well, hmm, weird. Let's see. Anyhow, go ahead. Bring down your 3x minus 4. Make sure you put that in parentheses times the log of 7. And we're going to set that equal to the log of 120. You see what's coming, right? It's going to take a little extra magic at the end. I'm going to show another step. I'm going to have 3x minus 4 equals the log of 120 divided by the log of 7. This will be the hardest one yet as far as calculator. So I'm gonna be a little bit delicate. I'm gonna show a little bit more work. So come along with me here. We're gonna have 3x now equals the log of 120 divided by the log of 7 plus 4, correct? But we have a new guy, the 3. And what's he gonna require that we do? Divide. So this is how it's gonna go on our calculators. This is what we're gonna type in. We're gonna type in the log of 120 divided by the log of 7, and we're going to do plus 4. And I'm going to pause here and I'm going to say something, and I'm going to be bossy about this because this is not up to you. This isn't a go rogue thing. You must hit enter right now. You must, unless you had chosen to put this whole thing in parentheses, which I'm guessing you didn't do of your own free will. So hit enter right now. And I'll catch up to you here. So we have log of 120, close, divided by log of 7, close, plus 4, enter. We should all be staring at 6.460284070, right? With that sitting on your scientific calculator screen, what are you going to do? So just hit divided by 3. You don't have to type in that whole decimal again. And we get around 2.15. Well, that's the worst 5 of all time. That's sorry you had to see that. 3, 4. Okay. Last one. Let's finish this job. Let's get this done. We're not going to have a lot of time to work, but surprise, surprise, right? Something different is going to happen this time. Something that we're not quite prepared for. So I apologize in advance. Sorry. I mean, not sorry. You know what I mean. Never mind. All right. Let's algebra. No, you saying divide by 9 makes me want to punch a baby. Yeah, let's subtract 52 from both sides first. So now we're looking at 9 times 4 to the power of negative 2x plus 1 equals, what is that, 62,096 maybe? I want to check my math. Is that okay? We're going to divide by 9 now, and something bad's going to happen. What is it? There's a decimal. So what we're going to do now is we're going to claim this, and you're not going to like this. And so I guess I am sorry about this, but not sorry enough to not make you do it. We're going to say that 4 to the power of negative 2x plus 1 equals 62,096 divided by 9. You have to tote this around now as a fraction, unless it's the kind of decimal that's manageable. Did you get an ugly decimal on your screen? Yeah. So what you don't want to do now is round that off. So this is the part that sucks, is you now cannot refer to that as a cute little happy number. You must now, to maintain precision accuracy, you must refer to it as 62,096 over 9. So sorry in advance. So let's look at what are the implications for us? Well, let's take a look. Let's bring down our negative 2x plus 1 and multiply it by the log of 4 and set it equal to the log of 62,096 divided by 9. I saved this for the end because if you were going to get mad at me, I thought we should just get angry on the last problem. When the division doesn't come out nice, we must preserve the integrity of the answer by leaving it as a fraction because fractions are perfect. Decimals are not. Now let's talk our way through the algebra. What comes next? Divide both sides by the log of 4, right? So where we're at in the process now is we have negative 2x plus 1 equals log of big ugly divided by log of super awesome 4. Now, algebra kicks in. What are the two algebraic steps? You've known this since 8th grade. Required to get x by itself. What are they? Subtract 1 and then divide by negative 2, right? So our answer that we're going to type into our calculator, sorry for working you up to the bell here. We got 4 minutes, by the way. So x is going to look like this. It's going to be log of big ugly divided by log of 4 minus 1. And what are we going to do on our calculators right there? We are going to hit enter to require it to calculate that first. And then after we hit enter, what are we going to do? Yes. Good. We're going to divide by negative 2. You're good, buddy. I felt that yawn. So let's type this in and see if we can pass this test. So here it goes. I'll walk you right through it. We're all going to hit log, and then we're going to just go in and we're going to type in 62096 divided by 9, close the parentheses, and then hit divided by. Log 4, close the parentheses, minus 1, enter. You're currently looking at a number on your screen that A, you don't care about, but B does say 5.3761, blah, 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 blah. Got it? And with that sitting on your screen, with it there, calculators are great. Just hit divided by negative 2, and we're done. So we can, on this one, say that x is approximately equal to negative 2.6881, because there's a 0 and a 7. So